In the dark spring of 1918, Paris stood on the edge of annihilation. The thunder of German artillery echoed from the horizon, and for the first time in the Great War, the heart of France itself seemed within reach of enemy fire. The German Empire's forces were advancing fast, sweeping across northern France in what they called the Kaiserschlacht, the Kaiser's battle, their final, desperate push to end the war before the Americans could fully arrive. And as the French government prepared to evacuate the capital, one weapon, a single legendary piece of artillery, would become the savior of Paris. Its name, the Canon de 75 modèle 1897. The French 75. A simple name, yet one that would go down in history as one of the most revolutionary guns ever built. This is the story of how one weapon changed warfare forever and saved a nation from destruction. Our story begins not in the chaos of war, but in the quiet aftermath of humiliation. The year is 1871, and France is reeling from one of the most devastating defeats in its history. The Franco-Prussian War has just ended in catastrophic failure. Napoleon III has been captured, Paris has been besieged, and the newly unified German Empire has paraded its troops down the Champs-Élysées in a calculated insult to French pride. The peace treaty strips France of Alsace and Lorraine, forces the payment of massive reparations, and leaves the nation traumatized and determined never to be caught unprepared again. In the French military high command, one lesson burns brighter than all others. Germany's victory was built on superior artillery. The Prussian Krupp cannons had devastated French positions, outranged French guns, and demonstrated that modern warfare was no longer about cavalry charges and bayonets. It was about steel, explosives, and the ability to rain death from a distance. For the next 2 decades, France poured resources into artillery development. They understood that the next war with Germany was not a question of if, but when. And when that day came, France needed to possess the most fearsome artillery in the world. The race was on, not just in France but across Europe. Artillery technology was experiencing a revolution driven by multiple innovations happening simultaneously. Smokeless powder, invented by French chemist Paul Vier in 1884, replaced the old black powder that had been used for centuries. This new propellant was 3 times more powerful, produced far less smoke so gun positions couldn't be spotted as easily, and didn't foul the barrel as quickly. Meanwhile, advances in metallurgy allowed for stronger gun barrels that could withstand higher pressures. Breech-loading mechanisms were becoming more sophisticated, allowing guns to be loaded from behind rather than the muzzle, dramatically increasing the rate of fire. And perhaps most importantly, high explosive shells filled with modern chemicals like melanite and TNT were replacing simple solid shot. But there was one problem that nobody had solved, one fundamental limitation that plagued every artillery piece in the world: recoil. When a cannon fires, Newton's third law of motion takes over. For every action, there is an equal and opposite reaction. The shell rockets forward with enormous force, and the gun itself is thrown backward with equal violence. In the 1880s and early 1890s, every field gun in the world was rigidly attached to its carriage. When it fired, the entire gun, barrel, carriage, wheels, everything, would lurch backward several feet. The crew would then have to manhandle the heavy weapon back into position, re-aim it carefully, and only then could they fire again. This process took time, lots of time. Even the best artillery crews could manage only about 2 or 3 aimed shots per minute. During those precious seconds between shots, enemy infantry could advance, cavalry could charge, or enemy artillery could rain down counter-battery fire. The army that could solve the recoil problem would possess a weapon of devastating power. Several engineers were working on the problem, but the breakthrough came from an unlikely source. A German engineer named Konrad Hausner had developed and patented a hydro-pneumatic recoil system in 1890. His design used a piston moving through oil and compressed air to absorb the recoil energy gradually, rather than allowing it to slam the gun backward. It was brilliant. But when Hausner presented his design to the German military, they were skeptical. The system seemed complicated, expensive, and potentially unreliable. The Germans passed on it. France did not. French military intelligence learned about Hausner's rejected patent, and engineers at the French artillery school immediately recognized its potential. If they could refine this design, miniaturize it, and make it reliable, they could create something extraordinary. It began in 1891 at the Bourges Arsenal, under the direction of Captain Saint-Clair de Ville. Working with Colonel Albert Deporte and engineer Émile Rimailho, they developed an experimental 57mm Canon that incorporated all the latest technologies: smokeless powder, a rotating screw breech mechanism, and most critically, a prototype hydro-pneumatic recoil system. The gun was revolutionary, but 57mm was too small for a field gun. The French army wanted something with more punch, more range, more destructive power. So the team scaled up their design. They moved to 75mm, a caliber that offered the perfect balance between shell weight, firing rate, and mobility. And they refined the recoil system obsessively, working in absolute secrecy because they knew they had something that could change the nature of war itself. The system they created was deceptively simple in concept, but diabolically complex in execution. Beneath the gun barrel sat a steel cylinder filled with oil and compressed air or nitrogen gas. Inside this cylinder was a floating piston connected to the barrel. When the gun fired, the barrel slid backward, driving the piston through the oil. The oil flowed through carefully calibrated holes in the piston, creating resistance that absorbed the recoil energy gradually and smoothly. Meanwhile, the compressed gas above the piston was compressed even further. Once the barrel reached the end of its rearward travel, the compressed gas pushed back, driving the barrel forward to its original position, ready to fire again. And here's the critical part. The gun carriage never moved. The wheels stayed planted. The trail remained in place. The gun itself absorbed all the recoil internally. For a gunner, this meant something almost miraculous. Once you aimed the gun, it stayed aimed. You could fire, and the barrel would slide back, then smoothly return to exactly the same position. Fire again, and again, and again, as fast as your crew could load shells. But the challenges were immense. The tolerances required were microscopic. The piston had to fit inside the cylinder with almost no clearance, yet it couldn't bind or leak. The oil had to be the perfect viscosity. The seals had to be flawless. This wasn't mass production. This was precision engineering at a level that had never been attempted for a military weapon. French craftsmen hand-fitted each recuperator, working with the precision of watchmakers. No two were exactly alike. Each was custom-built, tested, adjusted, and tested again until it worked perfectly. This made the design nearly impossible to copy. Even if someone stole the plans, they couldn't replicate the craftsmanship. By 1897, after 6 years of development, the gun was ready. The French conducted field trials, and the results were astonishing. A trained crew could fire 15 rounds per minute with devastating accuracy. The gun could engage targets at ranges up to 8,500 meters, more than 5 miles. The shells, whether shrapnel or high explosive, were lethal, and the gun itself was relatively light and mobile, able to be horse-drawn and set up quickly. On March 1898, the Canon de 75 Mod 1897 was officially adopted by the French Army. The military high command immediately classified everything about the gun as a state secret of the highest order. The hydro-pneumatic recoil mechanism was so secret that even French artillery officers were forbidden from seeing the piston itself during maintenance. Only specially trained technicians at depot-level maintenance facilities were allowed to work on the recuperator. Regulations prohibited anyone from photographing the mechanism. The French were so paranoid about protecting their secret that when the gun was demonstrated for foreign military attachés, the recuperator was covered with tarpaulins. The secrecy worked. Other nations knew France had a remarkable new gun, but they didn't understand how it worked. When the 75 was first demonstrated in 1898, foreign observers were stunned. They saw a gun crew firing round after round without re-aiming, and they assumed it must be some kind of trick. Surely no gun could actually do that. The French let them wonder. Soldiers called it le Canon miracle, the miracle gun. And when production began, France started building them by the hundreds, then by the thousands. By 1914, France had over 4,000 of these weapons, more than any other artillery piece in their arsenal. It was the backbone of the French field artillery, with every infantry division supported by an artillery regiment of 36 75-seconds. And France believed, perhaps too confidently, that this gun alone could win the next war. August 1914, the guns of August. The world exploded into the Great War. Germany launched its massive Schlieffen Plan, a sweeping invasion through Belgium, designed to encircle Paris from the north, while holding against Russian attacks in the east. The German army came like a grey tide, hundreds of thousands of men in Feldgrau uniforms, supported by heavy artillery, machine guns, and modern logistics. The French army, in contrast, marched to war in bright red trousers and blue coats, carrying their revolutionary doctrine of offensive spirit, Ebruffer Elan, which taught that moral force and aggressive attack could overcome any enemy. They were brave, determined, and about to be brutally educated in the realities of modern war. The opening battles were catastrophic for France. In the Battle of the Frontiers, French infantry charged German positions with bayonets fixed, bands playing, flags flying. German machine guns cut them down in windrows. French casualties in the first month of the war exceeded 300,000 men. The German advance seemed unstoppable. But then came the French 75s. At the Battle of Charleroi in late August, French artillery batteries deployed their 75 seconds and opened fire on advancing German columns. The effect was apocalyptic. The gun crews worked like machines, loading and firing, 15 rounds per minute, 900 rounds per hour from a single gun. The shrapnel shells burst over German formations, each one releasing nearly 300 lead balls in a deadly cone. The high explosive shells tore craters in the earth and shredded anything nearby. For German infantrymen who had been advancing confidently, the experience was terrifying. One German officer wrote in his diary that the French artillery fire was unlike anything they had expected. It wasn't sporadic or inaccurate. It was continuous, precise, and overwhelming. Entire battalions were pinned down, unable to advance or retreat, just trying to survive the steel rain falling from the sky. The Germans began calling the French 75 the Black Butcher, a grudging acknowledgement of its lethal effectiveness. But the German advance continued. Superior numbers, better coordination between infantry and heavy artillery, and the shock of modern warfare pushed the French back. By early September 1914, German forces had crossed the Marne River and were within striking distance of Paris. The French government evacuated to Bordeaux. Parisians who could afford to flee did so. The roads south were clogged with refugees. The fall of Paris seemed inevitable. The German First Army, under General Alexander von Kluck, was exhausted from weeks of continuous marching and fighting, but they could see the prize ahead. Paris, the capital of France, the symbolic heart of the enemy. Take Paris, and France would collapse. The war would be over by Christmas, just as everyone had predicted. But then came the miracle of the Marne. On September 5, 1914, French General Joseph Joffre the commander-in-chief, made a fateful decision: no more retreat. The French armies would turn and counterattack. He coordinated with the British Expeditionary Force and every available French unit. On September 6th, along a front stretching over 150 miles, the Allies attacked. The First Battle of the Marne had begun, and the French 75 was about to write its name in history. French artillery batteries positioned themselves on ridges and hilltops overlooking the Marne Valley. They had clear fields of fire. The German infantry, caught in open ground, became targets. The 75 seconds opened fire. Eyewitnesses described it as apocalyptic. The guns fired so rapidly that the sound merged into a continuous roar of thunder. The barrels glowed red-hot from the heat. Shell casings piled up around each gun position like brass snowdrifts. Crews worked frantically, sweat pouring, muscles screaming, loading and firing in a mechanical rhythm. Fire. The shell leaves the barrel at 575 meters per second. The barrel recoils smoothly, springs back, breech opens automatically, spent casing ejects, loader slams in a new round, breech closes, fire, again and again. American observer Mildred Aldrich, living just south of the Marne, described the scene. The battle had advanced over the crest of the hill. The sun was shining brilliantly, but many places were enveloped in smoke. From the east and west we could see the artillery fire. The hard thing to bear was all the guesswork. There was only noise, belching smoke, and long drifts of white clouds concealing the hill. In one documented action, a single French battery near Nanteuil-le-Haudouin engaged the German Lapel Brigade, caught in a beet field with no cover. In 5 minutes of continuous fire, that one battery killed or wounded over 2,000 German soldiers. The survivors broke and fled. The beet field became a charnel house. In another action near the village of Vaumarie, 100,000 German troops assembled for a massive night attack designed to overwhelm French positions with cold steel and courage. At 2 a.m. on September 10, they began their advance. Within minutes, French spotters detected the movement. The 75 seconds spoke. For hours, the guns poured fire into the advancing Germans. High explosive shells cratered the ground. Shrapnel shells burst overhead in airbursts that scoured the earth with metal. The German attack disintegrated. Bodies piled upon bodies. The survivors retreated in disorder, traumatized and defeated. On September 12th, after nearly a week of brutal fighting, the German army began to retreat. They pulled back to the Aisne River, dug in, and would not be dislodged for the next 4 years. Paris was saved, France was saved, and the weapon that had saved them was the Canon de 75 modèle 1897. French newspapers hailed the 75 as the father of victory. Soldiers spoke of it with almost religious reverence. It became a symbol of French technological superiority, French ingenuity, and French determination. Medals were struck with its image. Propaganda posters featured it prominently. It was the gun that had turned the tide, but the war was far from over. As the front stabilized into the nightmare of trench warfare, the limitations of the 75 became apparent. It was designed for mobile warfare, for shooting at infantry advancing in the open. Its shells were relatively light and lacked the power to destroy deep concrete bunkers and fortifications. Its relatively flat trajectory meant it couldn't reach enemy positions on reverse slopes. What the French needed now was heavy artillery. Howitzers and heavy guns that could lob shells high into the air and crash down into trenches. The Germans had these weapons in abundance. France did not. For the next 2 years, from 1914 to 1916, the 75 remained the backbone of French artillery, but it was supplemented increasingly by heavier weapons. At the Battle of Verdun in 1916, over 1,000 French 75 seconds were in action continuously for 9 months. They fired more than 16 million rounds, nearly 70% of all shells fired by French artillery during that horrific battle. The guns worked around the clock. Barrels wore out and were replaced. Crews rotated through. The 75 became as much a part of the Verdun landscape as the shattered forts and the omnipresent mud. It was at Verdun that the 75 truly proved its worth, not as a wonder weapon, but as a reliable, dependable workhorse that could keep firing day after day, week after week, month after month. Soldiers learned to love it, not because it was flashy, but because it was always there, always ready, always reliable. By 1917, the war had ground into a brutal stalemate. Millions were dead. Entire nations were exhausted. The French army mutinied in the spring of 1917. After yet another catastrophic offensive failed, the British were bleeding themselves white in Flanders. Russia collapsed into revolution and withdrew from the war. On the Western Front, everything hung in balance, and Germany knew they had one last chance. In March 1918, with Russia out of the war, Germany transferred nearly 50 divisions from the Eastern Front to France and Belgium. It was the largest concentration of German military power in the entire war. General Erich Ludendorff, effectively the military dictator of Germany, planned what he called the Kaiserschlacht, the Kaiser's battle. It would be a series of massive offensives designed to break the Allied lines before American troops could arrive in force. Operation Michael, the first phase, would punch through British lines on the Somme. Follow-up operations would hammer the French. If successful, Germany would win the war. If it failed, Germany would lose everything. On March 21, 1918, at 4:40 a.m., 10,000 German guns opened fire in the largest artillery bombardment in human history. For 5 hours, the earth shook. British trenches were obliterated, communications were severed, command and control collapsed. Then came the stormtroopers, elite German assault units trained in new infiltration tactics. They bypassed strongpoints, penetrated deep into British lines and created chaos. The British Fifth Army collapsed, entire divisions ceased to exist. Within days, the Germans had advanced 40 miles, the deepest penetration on the Western Front since 1914. Panic gripped the Allies. Operation Michael was followed by Operation Georgette in Flanders, then Operation Blucher York, aimed at the French. By late May 1918, German forces had crossed the Eisner River and were approaching the Marne once again. On May 27th, the Germans smashed through French positions near Soissons. By May 31st, they had reached Château-Thierry on the Marne, barely 50 miles from Paris. For the second time in 4 years, Paris stood on the edge of destruction. But this time something was different. This time the Americans had arrived. The American Expeditionary Force, commanded by General John J. Pershing, was green, inexperienced, and eager to fight. When the German advance threatened Paris, Pershing's chief of operations, Colonel Fox Connor, immediately recognized the crisis. American divisions were rushed to the Arbrecourt front. On May 31, 1918, elements of the U.S. 3rd Infantry Division arrived at Château-Thierry to reinforce French colonial units who were desperately trying to hold a bridge across the Marne. American machine gunners set up positions covering the bridge. French engineers prepared explosives to blow the bridge if necessary. On June 1st, German forces stormed Château-Thierry from the north. French and American troops fought side by side, machine guns hammering, rifles cracking. The Germans reached the bridge. The French blew it up. The Americans and French fell back to the southern bank of the Marne and dug in. For weeks they held that line. The Germans tried to cross. Artillery duels raged day and night. Snipers picked off anyone who showed themselves. But the line held. And all along that line the French 75 was there. Batteries of 75 seconds positioned themselves in villages, in woods, behind hills. They had perfect fields of fire across the Marne Valley. American artillerymen, many of whom had trained with the French, manned their own 75 seconds. The US Army had purchased thousands of them. Together, French and American gun crews created walls of fire that nothing could penetrate. On July 15, 1918, Ludendorff launched what he hoped would be the final offensive. German forces attacked both east and west of Reims in a massive pincer movement designed to encircle the city and open the road to Paris. The attack east of Reims failed immediately, stopped cold by French defense in depth. But southwest of Reims, German troops managed to cross the Marne in several places. For a few desperate hours, it seemed the line might break. Then the Allied artillery opened up. At Château-Thierry, a single French battery held off an entire German regiment trying to cross the Marne. For 36 hours straight, those gunners fired continuously. They fired until their ears bled from the concussion. They fired until their shoulders were bruised from loading shells. They fired until the barrels were so hot they glowed in the dark. Supply wagons raced back and forth bringing ammunition. Shells piled up, were loaded, were fired. The brass casings mounted in heaps, and the Germans kept coming, wave after wave, trying to force the crossing. And the guns kept firing. When the smoke finally cleared, the riverbanks were carpeted with wreckage. Helmets, rifles, bodies, the shattered remnants of boats and pontoon bridges. The German offensive had failed. Not a single German unit made it across the river in that sector. The French battery had held. Multiply that scene across the entire front. At Belleau Wood, American Marines and French troops fought a savage battle for every yard of shattered forest. French 75 seconds provided fire support, shelling German positions, breaking up counterattacks. The Americans took horrific casualties, but they held. At the Aisne River, French colonial troops and artillery stopped German advances cold. At Reims, the French defense in depth, anchored by artillery, prevented any breakthrough at all. By July 18th, just 3 days after the German offensive began, it was over. Not only stopped, but reversed. On July 18th, French forces, supported by American divisions and British units, launched a massive counter-offensive. Spearheaded by over 300 tanks and supported by massed artillery, the Allies struck the western flank of the German salient. The Germans, exhausted and overextended, broke. They began to retreat. The Second Battle of the Marne had turned the tide. For the second time, the Marne had saved Paris. And once again, the French 75 had been central to the victory. The statistics from the summer of 1918 are staggering. French artillery alone fired millions of rounds. The rate of fire from French 75 seconds was so intense that shell production couldn't keep up with demand. Factories across France worked around the clock. Women who had replaced men in the factories labored 20-hour shifts. Shell quality sometimes suffered due to shortcuts in manufacturing, leading to a rash of premature detonations and burst barrels in 1915. But by 1918, these problems had been largely solved, and the shells flowed in an endless stream. The tide had turned. Through the summer and autumn of 1918, the Allies pushed forward in what became known as the 100 Days Offensive. British forces, supported by Canadian and Australian divisions, smashed the Hindenburg Line. American troops fought in the Meuse-Argonne offensive. French armies advanced on multiple fronts, and everywhere the French 75 was there, supporting the infantry, breaking up counterattacks, destroying German positions. The gun that had been designed in the 1890s for a war of movement was finally being used in the kind of warfare it was designed for. Mobile operations, advancing infantry, targets in the open. It excelled. German forces, exhausted and demoralized, began to collapse. Revolution broke out in Germany. The Kaiser abdicated. On November 11th, 1918, at 11 a.m., the guns fell silent. The armistice had been signed. The Great War was over. As the final moments ticked away on that November morning, French artillery crews across the entire front fired one last synchronized volley, a salute to peace, a farewell to war. And then, silence. For the first time in 4 years, the guns were quiet. Soldiers stood in their trenches, stunned by the absence of sound. The war was over. The French 75 had fired its last shot, or so everyone thought. In the aftermath of the war, the French 75 became legendary. It appeared on war memorials across France. Its distinctive silhouette was featured on medals, coins, recruitment posters. Towns erected monuments featuring actual 75 seconds placed on pedestals. To the French people, the Canon D75 Mod 1897 was more than a weapon. It was a symbol of French technological prowess, French resilience, and French victory. Soldiers spoke of it with affection and respect. They had nicknames for their guns, treating them almost like living things. La 75, the 75, was mourned when damaged and celebrated when it performed well. The gun's reputation spread worldwide. During the war, the American Expeditionary Force had operated about 2,000 French 75 seconds. After the war, the United States tried to manufacture their own. But they ran into the same problem everyone did. The hydro-pneumatic recuperator was almost impossible to mass produce. Each one had to be hand-fitted by skilled craftsmen. The tolerances were measured in thousandths of an inch. There was no margin for error. The French had guarded the manufacturing secrets so jealously that even their allies didn't fully understand how to make them. Eventually, the Singer Manufacturing Company, yes, the sewing machine company, took on the challenge. It took them until 1919, after the war was over, but they finally managed to manufacture recuperators based on machine-made interchangeable parts. According to artillery historian Frank Comparato, the project was one of the most complicated engineering tasks ever attempted, one of the marvels of modern industry. Other nations bought thousands of surplus French 75 seconds. Poland, Belgium, Italy, Portugal, Spain, and various French colonies all operated them. The gun saw service in conflicts around the world. It was used in the Polish-Soviet War of 1919 to 1921. It fought in the Rif War in Morocco. It appeared in the Spanish Civil War. When World War II began in 1939, France still had about 4,500 French 75 seconds in service, now mounted on modernized carriages with pneumatic tires for truck towing. Many had been converted into anti-tank guns or anti-aircraft guns. When Germany invaded France in 1940, the 75 was still fighting. After France fell, the Germans captured thousands of them. They designated them as 7.5 centimeters FK 231F and used them on the Eastern Front and as coastal defense guns on the Atlantic Wall. The British, having lost most of their field artillery during the evacuation at Dunkirk, purchased 895 French 75 seconds from the United States. They mounted them on trucks as improvised tank destroyers and used them in North Africa and Italy. The Americans mounted their 75 seconds on M3 half-track vehicles, creating mobile gun platforms that fought across the Pacific, in North Africa, and in Europe. The French 75 even influenced tank design. The Saint-Chamond tank, developed in 1917, mounted a 75mm gun in its hull. The American M4 Sherman tank, perhaps the most famous tank of World War II, used a 75mm main gun that was directly inspired by the French 75. The gun's legacy extended well beyond France. But let's return to the question that started this story. How did one gun save Paris from total destruction? The answer isn't simple. It wasn't just the technical specifications, though those were revolutionary. It wasn't just the rate of fire, though that was unprecedented. It was the combination of technology, tactics, training, and timing The French 75 was the first truly modern artillery piece. It proved that rapid fire was possible without sacrificing accuracy. It demonstrated that field artillery could dominate a battlefield. It showed that technological innovation could provide a decisive advantage in warfare. At the First Battle of the Marne in September 1914, when Paris stood on the brink of capture, the French 75 provided the firepower that stopped the German advance. It didn't do it alone. French infantry fought with desperate courage. British forces anchored crucial positions. French leadership made brilliant decisions. But the 75 was the weapon that turned defensive positions into fortresses and German advances into killing grounds. Then, in the summer of 1918, when Paris faced destruction a second time, the 75 was there again. This time, it wasn't just French guns. American artillerymen had joined the fight, operating their own 75 seconds alongside their French brothers in arms. Together, they created barriers of fire that no enemy could cross. At Château-Thierry and Belleau Wood, along the Marne, the song of the 75 was the sound of salvation. The French 75 changed warfare. Before it existed, artillery was slow, cumbersome, and relatively ineffective. After it existed, every nation in the world rushed to develop quick-firing guns with recoil mechanisms. The principles it pioneered became standard in artillery design for the next century. Even today, modern artillery pieces use hydropneumatic recoil systems descended directly from the French 75's design. But beyond the technical legacy, there's something else. The French 75 represents a moment when human ingenuity, responding to an existential threat, created something revolutionary. It was born from defeat in 1871 and refined in secret workshops by engineers who understood that the next war would be won by whoever possessed superior technology. It proved itself in the most brutal testing ground imaginable, the battlefields of the First World War, and it saved not just a city but a nation, and perhaps Western civilization itself. Imagine if the French 75 hadn't existed. Imagine if France had gone to war in 1914 with only conventional artillery, at the Battle of the Marne without the devastating firepower of thousands of 75 seconds. Could France have stopped the German advance? Would Paris have fallen in September 1914? If Paris had fallen, would France have surrendered? And if France had surrendered, would Britain have fought on alone? The counterfactuals become dizzying, but the conclusion is clear: the French 75 mattered. In 1918, without the 75 supporting American and French forces at Château-Thierry, could they have held the Marne? If the line had broken and the Germans had reached Paris, would the war have ended differently? We can never know for certain, but we do know this: at two critical moments in the First World War, when Paris stood on the edge of destruction, the French 75 was there, and both times it helped save the day. Today, you can see French 75s in museums around the world. They sit on pedestals in French villages as war memorials. One stands in the courtyard of Les Invalides in Paris. Another is displayed at the Musée de l'Armée. The Australian War Memorial has one that was gifted by France in 1920 in recognition of Australian service. These guns are artifacts now, silent witnesses to history. But for 4 years, from 1914 to 1918, they were the most important weapons in the French arsenal. They were the guns that saved Paris. Twice. It wasn't the largest gun, it wasn't the loudest, it wasn't the most modern by the war's end, but it was the one that mattered most. Because when Paris was threatened, when France stood on the brink, when everything hung in the balance, it was the voice of the 75 that answered. Fast, precise, unyielding, devastating, 15 rounds per minute, 900 rounds per hour, hour after hour, day after day. The mathematical reality of that firepower is staggering. A single battery of 4 guns could fire 3,600 rounds per hour. An artillery regiment with 36 guns could fire 32,400 rounds per hour. Multiply that by the thousands of French 75 seconds in service, firing continuously across entire sectors of the front, and you begin to understand the scale of destruction they could inflict. It was industrial warfare in its purest form. Not the romance of cavalry charges or the nobility of single combat, but the mechanical efficiency of assembly line killing. The French 75 was a machine for producing death, and it was terrifyingly good at its job, but it was also, in a very real sense, a machine for defending life, for defending France, for defending Paris, for defending civilization itself against an invader. The men who designed it weren't warmongers. They were engineers who understood that France had been defeated before and was determined never to be defeated again. The men who built it weren't killers. They were craftsmen who took pride in their work, and the men who operated it weren't monsters. They were soldiers who loved their country and were willing to die to protect it. In the end, that's what the French 75 represented. Not just a technological marvel, though it was that. Not just a revolutionary weapon, though it was that too. But a symbol of a nation's refusal to surrender, a manifestation of French determination to survive. A tool that, at the critical moment, made the difference between defeat and victory, between occupation and freedom, between the end of France and its salvation. And in that thunder, that continuous roar of the guns firing across the Marne, across the fields of France defending Paris from destruction, there was a kind of terrible beauty. The sound of a nation saying, "We will not fall, we will not break, we will fight, we will endure, we will survive." And we did survive. France survived, Paris survived, the civilization we know today survived, because when it mattered most, when everything hung in the balance, one gun made the difference. The Canon de 75 modèle 1897, the French 75, the gun that saved Paris twice. This is its story, this is its legacy, and this is why, more than a century later, we remember.